In the last video, we saw how to solve a general cubic equation. And at the end there, it got kind of abstract. It looked really complicated, but we're going to play through this whole thing with an example now. And hopefully you'll see that it's really not that complicated. So the first thing we want to do is we want this factor right here to be 1. So we divide all of this by 2. So we'll get x to the third minus 3x to the second minus 3x minus 1 is equal to 0. Now the first step in solving a cubic equation was to get it into a form that looked something like this: y to the third plus some constant times y plus some other constant is equal to 0. Now, how did we do that? Well, if you can't remember how exactly the substitution looked, you can always do this. You can always say, I know that we used some sort of identity that looked like this. And that's really the same thing that you do in the quadratic equation, except that you know, instead of k over 2, you use k over 3, and instead of to the power of 2, you use to the power of 3. So what do you get? Well, this is equal to x to the third plus 3 times x to the second power times k over 3, so the 3's cancel out, plus x times k squared over 9, right? 3 squared, and I'm sorry, that should be 3 times, of course. 3 times x times k squared over 9 plus k to the third over 27. 3 to the third power, right? So these cancel out, and what we're left with is 3. So we know that x plus k over 3 to the third power is equal to x to the third plus x squared times k plus x times k squared over 3 plus k to the third over 27. Now, we wanted to substitute this with this. Well, or we wanted to rewrite this part of the equation with the identity of this. So we can rewrite this whole equation here as being x to the third plus x squared times k is equal to x plus k over 3 to the third minus x times k squared over 3, k squared over 3 minus k, whoa, I'm running out of space, minus k to the third over 27. So we can put this in there, and but we first have to figure out what our k is. Well, our k is this number right here. Let me color it in magenta. This right here. Well, what is our k here? It's -3, right? -3. It's a coefficient of the x to the of the x squared term, and that's our k, right? So it's -3. Now let's put this in. So what do we get? We get x plus -3 over 3, that's just -1 to the third minus k squared over 3. That's -3 squared is 9 over 3, which is 3, and we have a negative there, so it's -3x. And then we have negative k to the third. So minus 3 to the third is minus 27. Minus times minus is plus. So we get plus 27 over 27, which is 1, is equal to, oh no, and now we've only replaced this part. So we have to write the rest of this equation after it, right? X minus 3x minus 1 is equal to 0. Now we've simplified this already a bit. We can cross out the 1's, and what we're left with is x minus 1 to the third power minus 6x is equal to 0. Now remember, we wanted to get this equation into a form that looks like this. We're almost there. We have to the third power, and we have to the 1th power if you want, but we don't have a second power anymore. So let's try to get it into this form. And what can we do? We could say that y, and we're always doing the same thing. We could do this for any equation, so any cubic equation anyway. We were saying, well, this is going to be our y because it's to the power of 3, and so our y is equal to x minus 1, and so our x has to be equal to y plus 1, right? So our x here is equal to y plus 1, is equal to our x. So we can rewrite all of this by saying y to the third is equal minus 6 times our x. And what is our x? Our x is y plus 1, right? That's our x. And all of this is still equal to 0. Now let's multiply this out to get it into standard form. We have y to the third minus 6y minus 6 is equal to 0. Now we have our form that we wanted up here, right? This looks pretty similar. Now, the second step that we want to use, we're going to use the same identity again, but we're going to say m plus n to the third, and we can take any variables here, it doesn't matter, but just 2 that we haven't used yet. And we're going to say, well, this is equal to m to the third plus 3 times m squared n plus 3 times n squared plus n to the third, right? That comes straight out of the binomials, right? You just multiply this out. So if this is equal, so this minus this has to be 0, right? So we can write this m plus n to the third is equal to is minus all of this business here. All of this, we get minus 3m squared n minus 3m n squared, and I'm just going to group it already so we save a little space, minus n to the third. Now we can factor out the minus 3 and 1m and 1n out of each of these terms, right? So we get, and all of this is equal to 0. Equal to 0. I'm running out of space here. So m plus n to the third minus 3mn times m plus n, right? Because we factored out the negative 1 or the negative 3, so it becomes m plus n minus, and we're going to group these two. So m to the third plus n to the third is equal to 0. All of this business is equal to 0. Now, what we said was that this is obviously true for all numbers m and n. Now, can we find an m and an n that, if you add them together, become our y, right? Because that's what we want to do to solve this, is we want to find a y. And if we said, well, that is our y and this is our y, then what would negative 3mn have to be? So what would this have to be? Well, this has to be negative 6. And what would this have to be? Well, this would have to be negative 6 as well. So that's not a great example because, you know, we have 2 times negative 6. But you know, it's fine. So we could rewrite, we can write the equation negative 3mn is equal to negative 6. Right? So we could say that we could solve this for m. We have negative 6 over negative 3 over n, which is equal to 2 over n. Right? It's 2 over n, right? So the second equation we can write is this one. So that was the first one, right? This is this. And the second we can write is this one right here. We can say that minus m to the third plus n to the third is equal to this negative 6 right here. Is equal to negative 6. So the negatives cancel out, and we can put in m. We can substitute m with 2 over n. We've already done that. So 2 to the third over n to the third plus n to the third is equal to 6. Now we multiply all of this by n to the third, so we get rid of our fraction. So we get 2 to the third, which is 8, plus n to the sixth is equal to 6n to the third. So to get this into standard form, we can rewrite it like this: minus 6n to the third plus our 8, which is equal to 0. Now this doesn't look like it, but it's a standard quadratic equation, and we can solve that by substituting our n's, because we can say u is equal to n to the third, and so u squared is equal to n to the third squared, which is equal to n to the sixth. So we can rewrite this equation right here as being n to the sixth, as being u squared minus 6u plus 8 is equal to 0. Now to solve this, we just apply our formula, or we use the technique here with a x plus k over 2 squared substitution, but we're just going to use the formula for now. So the formula is negative b plus minus the square root of b squared minus 4ac over 2a. That is our u, right? So let's put our numbers in. Negative b, what is our b? Our b is negative 6. So negative 6, that is 6 plus minus the square root of negative 6 squared is 36 minus 4ac. So minus 4 times 1 is minus 4 times 8 is minus 32 over 2a. So 2 times 1 is 1. 2 times 1 is still 2. So what does this simplify to? This simplifies to the square root of 4, which is 2. Square root of 4 is 2, right? So we get our u to be equal to 6 plus minus 2 over 2. So we have u1, which is equal to 8 over 2, which is equal to 4, and we have u2, which is equal to 6 minus 2, which is 4 over 2 is 2. So now we can pick one of them. It doesn't really matter. Let's say we pick 4, and we want to solve for n, right? We substituted n. We want to know an n, so we can then find out what their m is, and then we can add up m and n, and we get our y, right? And with our y, we can then get our x, because we know that our x is y plus 1. So what is our n? What is our n? N is equal to the third square root of u. Well, what is u? Well, we just said that u is equal to 2 or to 4, whatever you want to take. Let's take 2. So we have our n. So what is our m? Well, our m is equal to, what did we say? It's equal to 2 over n, right? Up here we said that. It's 2 over n, which is the third square root of 2. I'm not going to use the blue color anymore. Actually, let me use the blue color. Over 2. So what is our y? Our y is equal to m plus n, right? We said our y is equal to m plus n, so it's equal to our m plus n, so it's equal to the third square root of 2, the third square root of 2, and now it's getting really difficult with the colors, plus 2 over the third square root of 2, the third square root of 2 of 2. Now we can simplify this a bit by saying y is equal to, well, let's just say the third square root of 2 times the third square root of 2 over the third square root of 2. Right? We can do that, because the third square root of 2 over the third square root of 2, that's just 1. So we can substitute this, or we can multiply by 1 anytime we want, because it doesn't change the value of our statement, right? So plus 2 over the third square root of 2. And I wanted to do that in blue, of 2, the third square root of 2. So let's see if we can't simplify this a bit further. So what do we get here? We have the third square root of 2 times the third square root of 2, so that would be the equivalent of 2 to the 1/3 power times 2 to the 1/3 power. So we can add those exponents up, right? So we'd get plus 2 over the third square root of 2. So if we add these exponents up, we get y is equal to 2 to the 2/3 plus 2 over the third square root of 2. Now, can we simplify this some more? Well, we could multiply this by the third square root of 2 to the second power. Why would we do that? Well, for the same reason that we just added up, for the same logic. Well, why would we do that? Well, what happens if we multiply this? If we multiply these two terms, what is this? This is 2 to the 1/3 times 2 to the 2/3, and we add those up, we get 2 to the 3/3, which is equal to 2, right? Because it's 1. So we would get rid of these square roots in the denominator. So let's do that. So what would we get? We would get 2 in the denominator, and we would get 2 2/3 times 2 to the 2/3 times 2 to the 2/3. That would be 2 to the 4/3, right? Plus 2 times the third square root of 4, right? 2 squared is 4. So what does that simplify to? Well, let me scroll down a bit. That simplifies to y is equal to the third square root of 2 to the 4th, which is 16, plus 2 times the third square root of 4 over 2. Now, I could say this is 2 to the third power times 2, right? So I could take a 2 out of there. Let me rewrite it. Let's say y is, actually, let me go over there. Let me continue this over there. So we have y is equal to the third square root of 2 to the third times 2 plus 2 times the third square root of 4 over 2. So this, let me switch colors. Maybe a green, haven't used that in a long time. This is equal to 1, to 2, right? The third square root of 2 is 2. So what do we get? We get y is equal to 2 times the third square root of 2 plus 2 times the third square root of 4 over 2. Now we can cancel the 2's out, and we get the third square root of 2 plus the third square root of 4 as one of our solutions for y. Now we're not done yet, because we wanted to solve for x, right? If we go all the way up, we had an equation where we wanted to solve for x, right? So what is x? X is equal to, right, this right here. X is equal to y plus 1. Well, this should be fairly simple. We have our y, so let's switch to yellow again. X is equal to y plus 1. We just, that's what we defined it as. So x is equal to y plus 1, which is equal to the third root root of 2 plus the third square root of 4 plus 1, and that is the first solution. So if we wanted to call it the first solution of our cubic equation that we formulated all the way up here. Now, for a cubic equation, you always have, or in a general case, you have 3 solutions, right? So what would be the other 2 solutions? Well, if you remember from the previous video, what you can do to get our x2 or to get our y2 is we can do a little bit of trickery with our unit square roots of 1, right? We said y is equal to m plus n. Now we said that another y we could calculate, would be e to the 120 times I times m plus an e to the 120 times I squared times n. Now what does that equal? So we have our y, and to calculate our x, we'd have to do the same thing all over again. We have to simplify our y and then add 1 to it. So what would we do? We would plug in our m's and our n's right into this equation down here, right? So what would that be? Let's just copy and paste this so we can let's just put that right down here. So what would our y1 be? Our y1 would be equal to e to the 120 times I times 2 over the third square root of 2 plus e to the 120 times I to the second power times times n, so times the third square root of 2. Now this is not going to be any fun at all, and this video has been quite long, but you can, if you want, multiply this out and simplify all of this and then add 1 to it, and you get your second x. And you could do for y2, you can do exactly the same thing. You can say e to the 120I squared times m times our m plus e to the 120 I, and I'm calculating these in degrees here, 120I to the second power times n, and once again you would go into normal form with these, and you would multiply these out, and so on and so forth, and then you would add 1 to them and you get your second x. So I hope you found that interesting. You just take all of this, you multiply it out, you add 1 to it, and then you get your x3 or your x2. So anyway, I hope you found that vaguely helpful. We've just solved a cubic equation that turned out to be quite a process.